Alright, and welcome to Factoring Quadratic Functions, Level 3. Now in problem 1a, it says solve the quadratic function below. So this is the same as everything that we've done, except for now there's a little bit of a problem. If I look here, in every previous problem, every a value has equaled 1. So remember, this is the a value, okay, we'll call it the a value. And here, our a value does not equal 1, and that's actually a problem. So in order to factor this, this is what I have to do. I'm going to go ahead and still set this equal to 0. And now I have my 2x squared plus 10x plus 12. And whatever my a value is, I want to divide every term by that. So I'm going to factor out this 2, or I'm going to divide out this 2, but I'm not going to divide the left-hand side by 2. So what do I mean by that? I'm going to write 0 equals, and remember, whenever you factor something out, it's almost like the reverse of distribution. That 2 comes down in front, and then my leftovers, I just reduce everything. I know 2 divided by 2 is 1, so I write 1x squared. And 10 divided by 2 is plus 5x. And 12 divided by 2 is plus 6. Now from here, I have to keep this 2, so I write 2 parentheses, parentheses. And now I just factor this like normal. I know that x times x gets me to x squared. And over here I can break down the 6. Remember, we break down our last term. And what two numbers multiply to be 6 but add to be 5? Well, that would be 2 and 3. Oh, 2 and 3. And so I can write plus 2 and plus 3. And so the cool thing is, once I factor out this 2, I essentially just get to ignore it. And I just set my factors, x plus 2 equal to 0, and my other factor, x plus 3 equal to 0. How do I get rid of the plus 2? Well, minus 2, and I get x equals negative 2, and minus 3, and I get x equals negative 3. Easy. We go graph this the same way. We go to negative 1, 2, and here's negative 3. And look, my a value, even though my a value is 2, it's still a positive 2. Now one note, anytime you have a number greater than 1, you're actually going to have a vertical stretch. What does that mean? It means that my graph gets narrower. So you might want to kind of draw this graph like very, very skinny. Okay? Cool. All right. I encourage you to come to the second example because I'm going to use a negative a value for the first time. And if you don't watch this, you'll miss everything with a negative a value. All right, let's get to it. Okay, in 7a, notice for the first time we have a negative a value. All right, so our a value is equal to negative 8. What's that going to tell us? Well, it's going to tell us that our graph is actually going to open downwards. So rather than an open up U-shaped graph, this is going to be a U that opens downwards. Okay, so let's go ahead and start this problem. I know that I still set f of x equal to 0. And here, I'll just go ahead and write out the problem. Negative 8x squared plus 24x plus 80. And remember, what I want to do is divide everything by my a term when it's not equal to 1. So I divide everything by negative 8. And what I'm going to say is I'm going to factor out that negative 8. Okay? And so now let's go through and reduce this. Negative 8 divided by negative 8 is 1x squared. 24 divided by negative 8 is negative 3x. And 80 divided by negative 8 is, in fact, negative 10. Okay, so now I can write 0 equals negative 8 parentheses, parentheses. And I know, of course, x squared breaks down into x and x. And remember, this one was the tricky one, negative 10. Well, one of my numbers has to be positive, one of my numbers has to be negative. And when I look at that middle term, that negative 3, let's go ahead and try positive 5 and negative 2. Is it true that 5 times negative 2 is negative 10? Yes. Is it true that 5 plus negative 2 is negative 3? No. It gives me positive 3. Well, that's incorrect. So what could I do here? Well, I could make my 5 negative and my 2 positive. A negative times a positive is still a negative. But negative 5 plus 2 is negative 3. And it turns out these are the two numbers that I want. Negative 5 and positive 2. Now from here, remember, we get to ignore that negative 8. Well, let's set our factors, x minus 5 equals to 0, and x plus 2 equal to 0. The opposite of minus 5 is plus 5, and x is equal to positive 5. And the opposite of positive 2 is negative 2. And so I can go graph this by going to the right 1, 2, 3, 4, 5. There's my first solution. And to the left 1, 2, and there's my second solution. But this is the important part. We have this negative a value, so what in the world are we going to do? Well, our graph opens down as such. And there you go. All right, I have one more example, and this one's a really tricky one, so I would highly encourage you to watch it, because in this one, our a term is actually going to be a fraction. All right, let's go to it. Okay, so let's go over 9a, and this is, I promise, way easier than you're probably thinking right now. It says solve the quadratic function below, and so we have f of x is equal to 1 over 3x squared plus 4 over 3x minus 5 over 3. And so, I want to change this 1/3. I want to change it where a equals 1. So what can I do? Well, I know that if I ever take any fraction, let's say like something like 1/2, and I multiply it by its reciprocal, so I don't divide, I multiply by its reciprocal, which is 2 over 1. Well, top times top, 1 times 2 is 2. Bottom times bottom, 2 times 1 is 2. And 2 divided by 2 is 1. If I multiply by the reciprocal, my a value becomes 1. So this is what we're actually going to do here, is we're going to multiply, let's change f of x into 0. And so I have 0 equals 1 over 3x squared plus 4 over 3x minus 5 over 3. And what I'm going to do is I'm actually going to multiply both sides times 3. So this is kind of entirely different from what we've seen before, but I'll multiply the right side by 3. I'll multiply the left side by 3. We're very fortunate because 3 times 0 is just 0. Okay, and so then 3 times 1/3, remember 3 over 3. Well, I'm going to give you the coolest trick in the world. When your denominator is the same as your numerator, they essentially reduce to 1 and go away. And check it out, 3 times 4 over 3, my denominator and my whole number are the same, they go away, so I get plus 4x. And over here, my denominator 3 and my whole number 3, they're the same, so they go away. So this is just a really cool trick. If you want to get rid of all your fractions and they all have 3's in the bottom, just multiply everything by 3. Easy, easy, easy. So we can go ahead and factor this now. And so x times x, of course, gives me x squared. But what would I break up this negative 5 into to get to a positive 4? And let's just go ahead and try positive 5 and negative 1. Let's see, 5 times negative 1 is negative 5, and 5 minus 1 is equal to 4. Okay, cool. So x plus 5 and x minus 1. Okay, from this point, we can set each factor equal to 0, like we've done every single time. And how do you get rid of a plus 5? Well, minus 5, and x is equal to negative 5. And how do you get rid of a negative 1? Plus 1, and x is equal to positive 1. Now let's go ahead and graph this. Go to the left 1, 2, 3, 4, 5, put my point, and I go to the right 1, and I put my point. And remember, our a value here was a positive 1 over 3, so this will still open upwards. All right? Thank you for sitting through all these examples. I hope that you find this, this assignment quite easy, and I'll catch you in our next video series.